Question 18. The graph of y equals 2x is shown. By drawing the graph y equals 3x squared subtract 4 on the grid, work out approximate solutions to 3x squared subtract 4 equals 2x. By drawing the two graphs on top of each other, we're looking for the x value where the two graphs cross, because that's the only point where they're equal. Whenever you're drawing a graph, you need to have a table of results, a table that shows what y would be in specific x values on the graph. We're already given a nice scale here from -2 upwards, so I'm going to experiment with the values of x equals -2, -1, 0, 1, and 2. Whenever you're dealing with x squared, it's always a good idea to have some negatives and some positives. We can always add new values to this later if we need to. So what does y equal in each of these scenarios? If x is -2, x squared would be 4. So 3 times 4 is 12, subtract 4 is 8. -1 squared would become 1, times 3 is 3, subtract 4 is -1. And you just continue to calculate what y would be in each of these scenarios. 0 squared times 3 is 0, subtract 4 is -4. 1 squared is 1, times 3 is 3, subtract 4 is -1. 2 squared is 4, times 3 is 12, subtract 4 is 8. You should always find a nice little turning point here because graphs of x squared are symmetrical. They create a nice parabola which will have a minimum or a maximum point and a nice smooth curve. Now, I'm not going to be able to draw a smooth curve using this computer program, but by hand you should always make sure that your graph is drawn with a smooth pencil curve to give you the best range of answers possible. Using these 5 possible coordinates, we're going to plot where the graph should be. -2, 8 goes across to -2 and up to 8, where I draw a small cross as close to that point as I can. -1, -1 means we go to cross to -1, down to -1, put a small cross. 0, -4, 1, -1, and 2, 8. There's no room to plot any further than this, so we don't need any more points. This is the point where you would draw a smooth freehand curve. I'm going to be very poor with my mathematics here and use a straight line between the points. This will actually throw off my approximation. It is much better to be a smooth line, but this will still give me a very rough approximation. Whenever you're dealing with a square value though, we should end up with a much smoother rounded curve with a pencil. That is a much easier task. Didn't like that line. If I was using a pencil and a ruler, this would be so much easier right now. Accuracy is everything when you come to these kind of graphs. Okay, once you've drawn your curve here, we're now looking for the points where the two graphs cross. Now this is an approximation, and if you've done a curve here, you're going to find that your results will probably cross a little bit further down towards this point here. The x value at that point, using the scale that we're given, is a -0.9. Whenever you read off your graph, you make sure that you're reading off the x value from the scale that you're given. For the other possibility, because we've crossed the line twice, there's a positive value right here. Again, if you've drawn a curve, you may find it's crossing something closer to this point over here, but I'm going to read off what mine says. In this case, it's 1.4, so my second possible solution for x would be approximately 1.4. You're just looking for the x value where those two lines cross, and you should always find that there are two solutions to an equation like this.